Today we are going to learn about mastering TSNE, avoiding common pitfalls. We will focus on identifying and avoiding common mistakes in TSNE visualization to produce accurate and insightful visualizations. Welcome to our video on mastering TSNE by avoiding its common pitfalls. In this video, we will learn how to enhance the accuracy and meaningfulness of your TSNE visualizations. By understanding the intricacies of TSNE, you can make more informed decisions based on your data visualizations. We will cover topics such as perplexity, random seed selection, and parameter tuning, all aimed at optimizing your TSNE plots for better insights. Let's dive into the details and unlock the full potential of TSNE.
Perplexity is a critical parameter in TSNE that influences the balance between local and global aspects of your data. It can be thought of as a smooth measure of the effective number of neighbors. The choice of perplexity can significantly affect the outcome of your visualization. Typically, a perplexity value between 5 and 50 is recommended, but it depends on the size and structure of your dataset. Too low a perplexity may result in capturing only very local data structures, while too high can blur the distinctions between data clusters. Experimenting with different perplexity values and evaluating the results can help in achieving a meaningful visualization. Remember, TSNE is sensitive to this parameter, and it's crucial to test and validate different settings to avoid skewed results. The random seed in TSNE determines the initial state of the random number generator used in the optimization process. This seed is crucial because it ensures that your TSNE visualizations are reproducible. Without setting a random seed, every run of TSNE could yield a different result, making it challenging to compare outcomes. To ensure consistency, always set a random seed when running TSNE. This practice not only allows for reproducibility but also aids in debugging and sharing your work with others. By doing so, you can confidently interpret and present your data visualizations, knowing they are consistent across different attempts.
TSNE is particularly useful for visualizing high-dimensional data. However, handling such data requires careful preprocessing to ensure meaningful visualizations. Before applying TSNE, consider using techniques like PCA or SVD to reduce the dimensionality of your data. This step can help in removing noise and speeding up the computation. Additionally, ensure that your data is scaled and normalized to prevent any features from dominating the TSNE result. By effectively managing high-dimensional data, you can make the most out of TSNE's capabilities, revealing insights that might otherwise be hidden. The curse of dimensionality refers to various phenomena that arise when analyzing data in high-dimensional spaces, often leading to inefficiencies and inaccuracies in data analysis. In the context of TSNE, it can affect the distance calculations between points, making it difficult to discern meaningful patterns. To combat this, consider employing feature selection techniques to reduce the dimensions to only those that are most relevant. Additionally, dimensionality reduction using PCA can help in alleviating these issues. By being aware of the curse of dimensionality and actively working to reduce its impact, your TSNE visualizations can become more accurate and insightful.
Interpreting TSNE plots requires a careful approach to avoid common misinterpretations. TSNE visualizations often reveal clusters which can represent underlying structures in the data. However, these clusters should not be taken at face value without further analysis. It's crucial to validate the clusters with additional data insights or complementary visualizations like heat maps or dendrograms. Misinterpretations can occur if TSNE plots are assumed to portray direct relationships or distances between points. Being aware of these pitfalls and using a holistic approach to data analysis will lead to more accurate interpretations of your TSNE visualizations. The number of iterations in TSNE determines how long the algorithm runs and refines the layout of the data points. Insufficient iterations can result in incomplete or distorted visualizations, while too many iterations may not yield significant improvements and can waste computational resources. It's essential to find a balance between time and accuracy. Monitor your visualizations for signs of insufficient iterations, such as poorly defined clusters or overlapping data points. Increasing iterations gradually and observing the changes can help in finding the optimal number for your specific dataset, leading to high-quality and reliable visualizations.
Handling large datasets in TSNE can be challenging due to computational and memory constraints. One effective strategy is to use an approximate version of TSNE, such as Barnes-Hut TSNE, which reduces the computational load by approximating pairwise distances. Another approach is to downsample your dataset, ensuring that the sample is representative of the entire data. It's crucial to balance performance with accuracy, as overly aggressive optimizations can lead to loss of important data insights. By employing these strategies, you can effectively manage large datasets in TSNE, making it a powerful tool for exploring complex data.
Parameter tuning is crucial in TSNE to achieve optimal visualizations. Key parameters include perplexity, learning rate, and the number of iterations. Each of these parameters affects the TSNE output in different ways, and finding the right balance is key. Start by experimenting with default settings and gradually adjust based on the results. Use visual cues from your plots to guide your tuning process. It's important to avoid overfitting, where the visualization captures noise rather than meaningful data structures. By following these best practices, you can fine-tune your TSNE parameters to produce insightful and accurate visualizations. In conclusion, mastering TSNE involves understanding and avoiding common pitfalls to produce accurate and meaningful visualizations. We've covered key aspects such as perplexity, random seed selection, and parameter tuning, all of which play a critical role in optimizing TSNE plots. By applying the strategies discussed, you can unlock the full potential of TSNE, gaining deeper insights into your data. Remember, practice is key to mastering these techniques. We encourage you to apply what you've learned and explore additional resources to further enhance your skills. Thank you for joining us on this journey to mastering TSNE.